When a blackout plunged 3 states into 11 days of darkness, most neighborhoods scrambled for candles. But one street in Ohio simply glowed. The light came from the windowsills, plants a 16-year-old had spent 2 years building in secret. Scientists had called her bioluminescent pothos a party trick. After the grid failed, that plant was the only light for miles. What did she know that the experts did? And why, when power returned, were researchers suddenly calling? Her name is Nora Vasquez. At 16, she built a glowing plant in her bedroom. No lab, no funding, just a second-hand microscope. Experts called it a party trick. Then the grid went dark for 11 days, and that plant lit the night. What we dismiss can save us. The story starts 2 years before the storm. 2 years before the blackout, Nora Vasquez was 14, sitting cross-legged on her bedroom floor with a second-hand microscope she'd saved 6 months of babysitting money to buy. She wasn't building a science fair project. She was building a question. Could a common houseplant, a golden pothos you can buy at any garden center for $12, be taught to produce its own light? Not reflected light from a bulb, not glow-in-the-dark paint. Actual bioluminescence, the kind fireflies use, the kind deep-sea creatures pulse into the abyss. The kind most people assume you need a multi-million-dollar laboratory and 3 PhDs to even attempt. Nora had neither. What she had was a stack of public domain genetics papers she'd printed at the public library. The complete DNA sequence for firefly luciferase downloaded onto a cheap laptop. And a stubborn, almost irrational refusal to believe that bioluminescence belonged only to professionals. She ordered a custom plasmid online using money from her after-school job at a pet supply store. The gene sequence arrived in a small, padded envelope, packed in dry ice, $47 total. Her parents, both high school teachers, looked at it the way you'd look at a mail-order chemistry set with no instructions. They trusted her, but they didn't quite understand her. Nobody did. The first 12 attempts failed completely. Plants died. Leaves yellowed. The glow, when it came at all, was so faint she could only detect it by sitting in total darkness for half an hour, letting her eyes adjust, and convincing herself she wasn't imagining it. She nearly quit after the 7th batch, when a contamination spread through her cuttings and took out everything she'd grown that month. But she started again, and again. She learned to work with Agrobacterium, the natural genetic engineer that inserts DNA into plants, a process she taught herself from a 2-hour YouTube lecture recorded by a professor in the Netherlands. By her 15th attempt, the roots were taking. By her 23rd, the first unmistakable greenish glow appeared on a leaf tip at 2 in the morning, and she woke up her parents to show them. By the spring of 2023, Nora had a stable line of pothos plants that glowed continuously, without batteries, without electricity, fed by nothing more than sunlight, water, and soil. She named the line Lucy, after the luciferase enzyme. She entered the Ohio State Science Day believing she'd built something meaningful. The judging panel did not agree. 3 university botanists listened to her presentation, examined her poster, and dismissed her in under 6 minutes. One called it a party trick with no practical application. Another, a plant geneticist from a Big Ten university, told her that amateur genetic engineering was irresponsible and possibly dangerous. He suggested she focus on a more traditional project next year. Nora didn't argue. She packed her cuttings, thanked the judges, and walked back to her parents' car in the parking lot without a word. But hear what nobody at that science fair understood. Nora had already given away dozens of cuttings to neighbors, to her aunt in Columbus, to her biology teacher who'd been the only adult to take her seriously. Those plants were alive in windowsills and on porches, emitting their quiet, steady glow every night, completely unnoticed. She didn't need a ribbon. She needed time. On the night of January 13, 2024, a massive ice storm swept across the Ohio Valley. Transmission lines snapped like dry twigs. Transformers blew in bright blue arcs. The grid failed hard and fast across 3 states. In Nora's neighborhood, the lights flickered once, then twice, then went out completely. For 11 days, they would not come back on. And everything the scientists had said about practical applications was about to be proven wrong. The first night of the blackout, the temperature dropped to 4 degrees. Nora's neighborhood fell into the kind of absolute darkness that city people rarely experience. No streetlights, no porch lights, no blue glow of televisions behind curtained windows, just ice cracking on tree branches and the occasional distant thud of a transformer giving up for good. The Reyes family 2 houses down had no candles. They'd meant to buy some after the last storm and never did. Maria Reyes, a nurse who'd just gotten home from a double shift, sat in her living room with her phone at 2% battery and a toddler who was afraid of the dark. And then she noticed it. A faint green light coming from the windowsill of her kitchen. It was the pothos plant Nora had given her 6 months earlier, a cutting in a mason jar she'd almost thrown out because it looked a little straggly. Now it was glowing steadily, a soft, even luminescence that threw visible light across the countertop and into the hallway. Maria carried it into the living room. Her toddler stopped crying. By midnight, the entire Reyes family was sitting in a circle around a plant, and for the first time since the power died, the house felt less like a coffin and more like a home. Word travels fast in a blackout, not through social media because the cell towers were down too, through actual footsteps. Neighbors walking door to door, checking on each other, sharing what little they had. And in house after house, the same discovery repeated itself. The Hendersons' porch pothos glowing under a dusting of snow. The Loom family's kitchen window, lit green from a plant they'd stuck in a corner and forgotten about. Nora's aunt in Columbus, 50 miles away, called later to say her cutting had lit the entire stairwell. Nora herself hadn't realized how many cuttings she'd given away. Dozens, maybe more. Every single one, it turned out, had survived. Every single one now lit the dark. By day 3 of the blackout, a local news crew from WKYC in Cleveland had heard about the glowing plants through a ham radio operator. They drove out on icy roads with a generator and a camera, expecting a quirky human interest story. What they found was a subdivision that looked like something out of a fairy tale. Porches bathed in soft green. Families gathered around their plants like campfires. One man told the reporter he'd been able to read a book by his pothos, the first time he'd picked up a book in years. The footage aired that night on a generator-powered broadcast, and even with limited reach, it took off. Someone uploaded a clip to a satellite internet connection. Within 48 hours, the video had been shared 200,000 times. That's when the scientists started calling. Not all of them were friendly. The plant geneticist who dismissed Nora at the science fair, a professor named Dr. Harlan Webb, appeared on a morning radio show and doubled down. He said the plants posed a potential environmental risk because they'd been distributed without regulatory oversight. He used words like rogue biotechnology and containment failure on a national broadcast, while thousands of people were still using those same plants to navigate their homes in the dark. The irony was lost on no one except, apparently, Dr. Webb, but behind the scenes his tone was different. Nora's parents received an email from his university's technology transfer office. It wasn't a cease and desist. It was a request. Could they send samples? Would Nora be willing to sign a materials transfer agreement? The same institution that had dismissed her work as a party trick now wanted to study it before anyone else could. Other players entered fast. An agricultural biotech firm in St. Louis offered $50,000 for an exclusive license to Nora's specific genetic modification method. A venture capitalist from San Francisco called and offered twice that, plus a college fund if she'd agree to a face-to-face meeting. Nora was 16. She was still turning in homework online during the blackout, sitting in a library that had backup power. She didn't have a lawyer. Her parents, both biology teachers, understood enough to be terrified. They could see what was coming before Nora could. This plant wasn't just a curiosity anymore. It was about to become a battleground. The pivot came on day 7. The USDA's Animal and Plant Health Inspection Service issued an official inquiry. Someone, it was never clear who, had filed a formal report alleging that Nora's cuttings constituted an unapproved release of a genetically modified organism into the environment. The letter arrived by email, cold and bureaucratic, full of regulatory codes Nora had never heard of. It asked her to provide a list of every person who'd received a plant, the exact genetic sequence she'd used, and a detailed plan for containment. Failure to comply could result in civil penalties. The plant that was lighting an entire neighborhood suddenly sat in the shadow of a federal investigation. And then, in the middle of that chaos, something else happened. Nora received a message from a different kind of scientist. Not a university professor, not a company executive. An agricultural researcher at a small nonprofit dedicated to sustainable lighting solutions for developing countries. His name was Dr. Amari Cohn, and he'd seen the footage from Cleveland. He wrote a single paragraph. No offers, no threats. He simply said, "I think what you've built might change how the world thinks about light. When this is over, I'd like to help you if you want it." Nora read his email on her phone, still charging off a neighbor's generator, surrounded by the green glow she'd built from nothing. She had no idea what to do next, but for the first time since the grid failed, she had a reason to believe that the party trick might just matter enough to survive what was coming. The question was no longer whether the plant worked. It was whether the system would let it. And in 48 hours, Nora would have to make a choice that no 16-year-old should ever have to make. The 48 hours started at 8 a.m. on a Tuesday, and Nora spent the first 2 of them sitting in the dark. Not the blackout dark. The power had flickered back on briefly that morning before failing again. But the dark of knowing that a federal agency had her name on a file, and no amount of bioluminescence could make that go away. Her parents sat at the kitchen table with the USDA letter printed out between them, the ink smudged from being handled too many times. The letter didn't ask questions. It demanded answers. A complete list of recipients, the exact genetic sequence, and a containment strategy for plants that were now scattered across 3 counties and counting. Failure to comply, the letter stated, could result in civil penalties of up to $250,000. Nora's father, a man who had spent 20 years teaching 10th grade biology, read that number out loud 3 times, as if repetition might make it smaller. Then things got worse. A reporter from a national newspaper had gotten hold of the USDA inquiry through a public records request and published a story with a headline that made Nora's stomach drop. Teens glowing GMO escape threatens Ohio ecosystem, experts warn. The article quoted Dr. Harlan Webb at length. He called the situation an unprecedented case of unregulated environmental release and suggested that the pothos, a notoriously invasive plant in warm climates, could theoretically cross-pollinate with native species. He offered no evidence that this was even biologically possible, but the word invasive did its work. Online forums erupted. Some called Nora a hero, others called her a bioterrorist. A 16-year-old who'd wanted to make a plant glow had suddenly become the center of a national debate about genetic engineering, scientific gatekeeping, and who gets to decide what technology is too dangerous for ordinary people to touch. But here's what the headlines missed. While the controversy raged, Nora's plants were still glowing, and people were still using them. A nursing home in Toledo that had received a cutting from a staff member reported that the plant had provided the only light in the memory care unit during the blackout, calming residents who were terrified of the dark. A midwife in rural Kentucky delivered a baby by the light of a pothos when the generator failed. These stories trickled in through social media and local news, not with outrage, but with gratitude. The gap between what the public was experiencing and what the experts were warning about was widening by the hour. On the morning of the second day, with 30 hours left on the informal deadline she'd set for herself, Nora received an unexpected ally. The biology teacher who'd taken her seriously, a woman named Ms. Elaine Okonkwo, drove through the ice and showed up at the front door with a thermos of hot chocolate and a flash drive. On the flash drive was a petition signed by over 3,000 people, neighbors, former students, strangers from around the world, demanding that the USDA stand down and allow Nora's work to continue. But more importantly, Ms. Okonkwo had brought a contact. A lawyer from the Electronic Frontier Foundation who specialized in citizen science cases had agreed to represent Nora pro bono. The lawyer's message was simple. You didn't break the law, Nora. The law hasn't caught up to what you did. That's not your fault. And then came the bigger bombshell. Dr. Amari Cohn, the nonprofit researcher who'd reached out days earlier, sent a second email. He had been following the USDA situation and wanted Nora to know that his organization, the Global Sustainable Light Initiative, was prepared to help her file for an experimental use permit that would bring her plants into full regulatory compliance. But there was a condition. The biotech firm in St. Louis had already approached him, offering to fund his research in exchange for exclusive access to Nora's genetic sequence. Cohn had refused. He told Nora that if she signed with a corporation, her plant would become a product, locked behind patents and pricing. If she partnered with his nonprofit and released the sequence into the public domain, it could become a tool, free for anyone to use, anywhere in the world where the grid was unreliable or non-existent. The choice was hers: $50,000 and a college fund on one side, open-source global impact on the other, and she had to decide while the USDA was still deciding whether to fine her into silence. Nora sat on her bedroom floor that night, the same floor where she'd built her first failed cuttings, the same floor where she'd seen the first real glow at 2 in the morning. The plant in the corner was still glowing. She looked at it for a long time, and for the first time since the blackout began, she didn't see a science experiment. She saw a choice about what kind of world she wanted to build. The storm outside was finally easing. The grid was coming back neighborhood by neighborhood. But the decision she made in the next 12 hours would set the course for everything that followed. At 6 a.m., Nora sent Dr. Cohn a one-sentence email. "Tell me what I need to sign." She had not slept. Her parents had not tried to stop her. They knew their daughter well enough to know that a kid who spends 2 years in a bedroom teaching a plant to glow doesn't make decisions based on fear, and she doesn't make them based on money either. By 9 a.m., the Global Sustainable Light Initiative had a signed memorandum of understanding. The genetic sequence for Lucy, the glowing pothos that a panel of university botanists had dismissed as a party trick, would be published in the public domain under an open-source license. No patents, no exclusive rights. Any researcher anywhere could build on it. The biotech firm in St. Louis withdrew their offer within the hour, and that was fine. Nora was already recording a video in her bedroom, the same room where it all started, explaining her decision directly to the hundreds of thousands of people who had followed the story. The video was simple. Her, the plant, no script. It got more views than the original news clip that had started everything. The USDA inquiry took longer to resolve, but the direction it went surprised everyone. The lawyer from the Electronic Frontier Foundation, working with Dr. Cohn's team, filed a formal response that didn't just defend Nora. It made a case. They argued that citizen science, when conducted with the care Nora had demonstrated, posed no greater risk than the thousands of unregulated plant hybridization experiments that happen in backyard gardens every year. They submitted letters from the nursing home in Toledo, from the midwife in Kentucky, from families who had navigated 11 days of darkness by the light of a plant. The agency had two choices: pursue a penalty against a 16-year-old whose invention had harmed no one and helped many, or use the case to establish a framework for responsible amateur biotechnology. On March 2, 2024, the USDA issued its final determination: no penalty. Instead, they invited Nora to participate in a working group on public engagement in genetic engineering, alongside professors, policymakers, and yes, Dr. Harlan Webb. Webb, the plant geneticist who had dismissed Nora at the science fair and later called her plants an environmental threat on national radio. He did not apologize publicly. He never retracted his statements. But something else happened that mattered more. In April, a team at the University of California, Davis, published a peer-reviewed analysis of Nora's method. They concluded that her gene insertion was stable, that the luciferase enzyme posed no known ecological risk, and that the light output of her pothos was, to quote the paper, surprisingly efficient for a first-generation amateur construct. The paper cited Nora Vasquez as the originator of the sequence. In academic publishing, that counts as recognition, and Webb, as a reviewer, had signed off on it. He never said a word to Nora directly, but the signature was enough. And here's a detail that almost nobody knows. The week the UC Davis paper came out, Nora received a handwritten note in the mail, no return address. Just a single sentence on a plain yellow note card. I was wrong to call it irresponsible. It was signed with a typed name, H. Webb. She didn't post it online. She kept it in the same notebook where she'd logged her first 23 failed batches, the one with the coffee stain on the cover and the pages that smelled faintly of soil. She showed it to her parents, and then she put it away and went back to work. Because by then, the work had gotten bigger. Dr. Cohn's organization, with Nora's sequence now in the public domain, had launched a pilot program in off-grid communities in Rwanda and Nepal. The plants wouldn't replace solar panels or generators, but they could provide a small, steady, zero-cost light source for households that otherwise burned kerosene, which is expensive, polluting, and a known cause of respiratory illness. Early field tests showed that a single mature pothos cutting, kept near a window during the day, could provide enough light at night to navigate a room, check on a sleeping child, or read a single page of a book. It wasn't a revolution. It was something quieter. A beam of light in a place where there had been none, built by a teenager who had refused to believe that practical application was only for professionals. The full circle came in June. Nora was invited to speak at the same Ohio State Science Day where, 15 months earlier, she had been dismissed in under 6 minutes. She stood on the same stage in front of a different panel of judges and told the story from the beginning. The second-hand microscope, the $47 plasmid, the 13th failed batch, the first glow at 2 in the morning. When she finished, the audience stood up, not for the standing ovation. They stood up because the lights in the auditorium, as part of a planned moment, dimmed to black. On the stage, on a small table beside Nora, a single golden pothos glowed steadily in the dark. The silence lasted maybe 5 seconds. It was all the answer anyone needed. What nobody in that auditorium knew was that Nora had already started her next experiment, working with a team of volunteers to see if the luciferase pathway could be adapted to produce a plant that glowed in response to specific environmental toxins. A living sensor. A warning system. She was 17 now, with a lab that was still her bedroom, and she was still asking the same question she'd been asking since she was 14. What else can a plant learn to do? The scientists who had dismissed her were quiet now. The plant was still glowing. And somewhere in Ohio, on a windowsill in a house that had survived 11 days without power, a cutting of Lucy was still growing. The story was never just about a plant. It was about who gets to decide what's useful, whose work matters, and whether a 16-year-old with a second-hand microscope deserves a seat at the table. Nora Vasquez didn't wait for permission. She built her answer leaf by leaf, in the dark, long before the grid failed and the world noticed. The experts who dismissed her had credentials and reputations. What they lacked was what every true scientist needs most: the humility to recognize that discovery doesn't always arrive wearing a lab coat. Sometimes it shows up as a quiet teenager with dirt under her fingernails and a plant that glows. The grid came back. The news cycle moved on. But what happened in those 11 days reopened a question that matters far beyond one neighborhood in Ohio. How much brilliance do we ignore because it doesn't come with the right paperwork? If this story reminded you to look twice at the things the world has already written off, subscribe and tell us in the comments about a time you were underestimated. Like this video if you think the next world-changing idea is probably sitting in someone's garage right now. Share this with someone who's building something nobody believes in yet. And as always, let us know where in the world you're watching from tonight. Because the next Nora Vasquez is out there right now, probably in a bedroom somewhere, failing over and over again at something everyone else says doesn't matter. And if we've learned anything from a 14-year-old who bought a second-hand microscope and refused to take no for an answer, it's this. One day, when the lights go out, we might be very glad she didn't stop. That's the kind of light that doesn't need a power grid.